After much deliberation and going back and forth, we found that these 6 levels work well for students and for us. In order for students and parents to really see progress, we found we needed small steps. In addition, we want the rubric to have enough information to provide guidance and still be readable and comprehensible. For those of you who would like more information about how to create the learning progressions, please see the Essentials of the Learning Progression Model at www.reimagineschools.com. Grant Wiggins said, and I agree, to be useful, feedback must be consistent. Clearly, performers can only adjust their performance successfully if the information fed back to them is stable, accurate, and trustworthy. In education, that means teachers have to be on the same page about what high-quality work is. In an effort to make these progressions consistent and the feedback more stable, we use what we call anchor words associated with each developmental level of the learning progression. Not enough evidence means exactly that. If the student doesn't provide enough work or doesn't turn in an assignment or answer a question, there simply is no way for me to provide any feedback on whether or not he or she has mastered any portion of that practice. It's another way of saying I reserve judgment. But since my job is to evaluate progress, earning and not enough evidence means that a student really can't pass the course. Beginning means try to respond. Developing means responding with some relevant information. Proficient means the student explicitly uses physics in their response. Advanced means the response is accurate, and expert means the response is complex or sophisticated, usually by tying in multiple concepts. These are the words that I use to try to keep everything uniform. I like to use the analogy of a ladder for performance levels. One must step on the previous rung before attempting to move to the next one. Therefore, students must achieve beginning before they move to developing. Notice how, unlike a real ladder, these rungs are not equally spaced out. That's because as you move towards more complexity, there are many more items to address, and so it's a lot more to manage. So we move pretty quickly initially from beginning to developing, and then we spend a long time working on proficient and even longer to get to advanced. And you'll see this when we get to talk about how we develop these skills. Back in the video, The Practices, I presented all 10 practices and their goals. Here's one, creating explanations and making predictions. The goal is to show what physics you know and can apply from the current unit of study. The physics can take the form of overtly stated definitions, laws, mathematical models, equations, or relationships. So how does that translate into a learning progression? The first thing that a student should do is try. Write an explanation, any explanation that they believe will answer the question. You can't produce a right explanation if you don't begin by writing something. The next step is to use the applicable vocabulary that you've picked up during class while learning the unit content. That's developing. Just be relevant. To build on that, define those terms so that I can tell you actually understand what they mean and how they apply. You could be wrong in that application, but the meaning of the physics terms should be correct in order to earn proficient. Only after that do we look for the application to be correct. And then the expert level draws in physics from other units of study. So we try to make progress using the skills throughout the year, even as the content changes. Let's do that again for another one. Let's talk about problem solving. The goal is solving scientific problems, right? Showing the process used. The problem-solving process includes givens and variables on a labeled sketch or illustration, relevant diagrams, equations used, numbers plugged in, and an answer to the question asked with necessary units on all values. So how does that translate to a learning progression? The first thing, again, that you should do is try. Write down any information that you believe will lead you to a solution. You can't possibly solve a problem if you don't start writing. The next step is to show any of the relevant steps that you've picked up during class, any of the ones listed in the descriptors. Listing givens, drawing a sketch, making some diagrams, putting down an equation, the numbers that you're plugging in, coming up with an answer, all of that is developing. To build on that, I have to be able to follow your work. You have to work systematically so I can follow your thinking, even if there are errors or omissions. You can be wrong in the application, but the steps themselves should be correct to earn proficient. Only after that do we look for all those steps to be completely correct. And again, expert level adds in complexity where strategies and information from multiple units are needed to solve the problem. Again, we're trying to make progress using the skills throughout the year, even when the content changes.